In this video, we'll go through exam questions that cover the criteria, draw and interpret scatter diagrams, and recognize positive and negative correlation. You can locate the questions on the mathsmaths.com website under Level 2. The questions come from different exam boards. We'll start with the non-calculated questions and then we'll move to the calculated questions. Here is the first one. This scatter diagram shows the relationship between forecast temperatures and actual temperatures for the town over 9 days. The line represents the points at which the forecast and actual temperatures are the same. A forecast is recorded as accurate if the actual temperature is within 2 degrees Celsius of the forecast temperature. Zach writes that the temperature forecast was accurate for less than 70% of the time. Is that correct? Show how you decide. So we've got forecast temperatures and actual temperatures. These ones within the line, they are accurate. So we've got this one here, forecast as 7 degrees, but the actual temperature was 7.5. So that is within the 2 degrees that we've got the criteria here to be counted as accurate. So that is also accurate. Looking at this one here, forecast as 8 degrees and it was nearly 7 degrees. So that again is accurate. Looking at this, forecast at 10 degrees and it was at 6.5. So that's not accurate. This one, forecast at 11, but it was actually 8. So again, that's not accurate. This one, forecast 13 degrees, but in reality it was 12. So only 1 degree difference. And that counts as accurate. This one here was forecast to be 13, but it was something like 14.2, which again tells us that it's accurate. This one, forecast at 15 degrees, but it was 18, so not accurate. This one, forecast at 16 degrees, but it was nearly 20. So again, not accurate. So how many of them in total were accurate? We've got 1, 2, 3, 4, 5. 5 out of 5, 6, 7, 8, 9. So 5 out of 9. So is 5 nines more or less than 70%? 5 nines means 5 divided by 9. How many 9s fit into 5? None, 0. So we have 5 remaining. We've run out of digits, so we're going to put a decimal point here and in the answer as well. And we can add zeros after that point. So how many 9s into 50? That is 5, because 5 times 9 gives us 45. And we have 5 remaining. Again, we can add zeros here. So how many 9s into 50? That is 5 again. And we have 5 remaining. So as you can see, the pattern continues. So 5 nines is equal to 0.555 with a 5 recurring. Now, as a percentage, that will be 55.55%. That is less than 70%. So Zach is correct. Jackie is training for a cycle race. She reads a cycling blog. It says that cyclists should aim to keep their heart rate above 72% of their maximum heart rate. Jackie uses this formula to work out her maximum heart rate. M is equal to 191.5 minus 0.007 times A squared, where M is the maximum heart rate in beats per minute, A is the age in years. Jackie is 25 years old. This scatter diagram shows the relationship between power in watts and heart rate beats per minute. To produce 100 watts of power, a cyclist uses about 350 kilocalories per hour. Estimate the number of kilocalories Jackie uses per hour if she cycles at 72% of her maximum heart rate. So we'll first work out Jackie's maximum heart rate. So the maximum heart rate is equal to 191.5 minus 0.007 times age in years squared. What is 25 squared? So we'll do 25 times 25. 5 times 5 is 25, so 5 down, 2 carried over. 5 times 2 is 10, and the 2, that is 12. Putting 0 down, 2 times 5 is 10, so 0 down and 1 carried over. 2 times 2 is 4, and the 1 is 5. So 625. So we now have 191.5 minus 0.007 times 625. So we have two operations, subtraction and multiplication. Again, we need to do multiplication first. So we'll do 0.007 times 625 before we do the subtraction. So starting with the units, 5 times 7 is 35, so 5 down, 3 carried over. 5 times 0 is 0, and the 3 is 3. 5 times 0 is 0, 5 times 0 is 0. Finished with a 5, so we put a 0 down. 2 times 7 is 14, so 4 down and 1 carried over. 2 times 0 is 0, and the 1 is 1. 2 times 0 is 0. 2 times 0 is 0. We finished with a 2 as well. Now we're moving to the 6. So we'll need to put 2 zeros down now. 6 times 7 is 42. So we'll put 2 down and 4 carried over. 6 times 0 is 0, and the 4 gives us 4. 6 times 0 is 0, and 6 times 0 is 0. So 5, 7, 3, 4, 0, 0. So the first number has 1, 2, 3 decimal places. Second number doesn't have any because it's a whole number. 625 is a whole number. So we're going to give the answer in total 3 decimal places. So going backwards, 1, 2, 3. So the answer is 4.375. So we're going to do now 191.5 minus 4.375. You can fill these two with zeros. So we're taking away 5 from the 0, which means we've got to borrow. But we haven't got anything in here. It's a 0. So we're going to borrow from the 5. So this becomes 10. Now we can borrow from the 10. So 10 take away 5 gives us 5. 9 take away 7 gives us 2. 4 take away 3 gives us 1. We're taking away 4 from the 1, which means we've got to take away or borrow 1. So take away 1 from the 9. This becomes 11. So 11 take away 4 gives us 7. 8 take away 0 gives us 8. 1 take away 0 is 1. So 187.125. So we now have the maximum heart rate for Jackie. We now can work out 72% of her maximum heart rate. So we're working out 72% of 187.125. So 10% of 187.125 is worked out by dividing the number by 10. So that will give us 18.7125. So we move the decimal point one place to the left to make the number 10 times smaller. So that is 10%. 70% we can get by multiplying this number by 7. So 7 times 5 is 35. 5 down, 3 carried over. 7 times 2 is 14. And the 3, that is 17. So 7 down and 1 carried over. 7 times 1 is 7. And the 1 is 8. 7 times 7 is 49. So 9 down, 4 carried over. 7 times 8 is 56. And the 4 gives us 60. So 0 down, 6 carried over. 7 times 1 is 7, and the 6 gives us 13. Now to place the decimal point, the first number has 1, 2, 3, 4 decimal places, and the second number has no decimal places because it's a whole number. So we're going to give the answer 1, 2, 3, 4 decimal places. So 130.9875. That is 70% of 187.125. We need to add 2% as well. So 1% of 187.125 is equal to 1.87125. So now moving the decimal point 2 places to the left to make the number 100 times smaller. 2% is going to be double that. So I'm just going to add another 1.87125. 5 and 5 is 10, so 0 down, 1 carried over. 2 and 2 is 4, and the 1 is 5. 1 and 1 is 2. 7 and 7 is 14, so 4 down, 1 carried over. 8 and 8 is 16, and the 1 is 17. 7 down, 1 carried over. 1 and 1 is 2, and the 1 is 3. So we now need to add that on top of the 70% amount. So 130.9875 plus 3.74250. So we have 5 and 5, which is 10, 0 down, 1 carried over. 7 and 2, 9, and the 1 gives us 10. So 0 down, 1 carried over. 8 and 4 is 12, and the 1 is 13. So 3 down, 1 carried over. 9 and 1 is 10, and the 7, 17. 7 down, 1 carried over. 3 and 1 is 4. 3 and 0 is 3. 1 and 0 is 1. So 72% is 103 134.73, which is about 135. So So 135 is about here, but first we need to draw a line of best fit. So a line that goes roughly through the points. So you create equal distance from the line and the points on both sides. So I've just drawn a line that roughly goes through the points, and when it comes to these questions, it's always estimation because you can't be absolutely accurate. So as long as you trying to go through the points and keeping more or less an equal distance between the line and the points on both sides, you should be absolutely fine. So now going back to 135 beats per minute, that is here. So where does that meet the line? It's about this point here. Which is 170 watts. So to produce 100 watts of power, a cyclist uses 350 kilocalories. What about 170 watts? So from 100 to 170, it's like 70% has been added on top. So there is a 70% increase. So we'll need to do the same to 350. So what is 70% of 350? We know that 10% is 35. So 70% is 35 times 7. 7 times 5 is 35, so 5 down and 3 carried over. 7 times 3 is 21, and the 3 is 24. So 70% is 245. So we're going to add that on top of 350. 0 and 5 is 5, 5 and 4 is 9, 3 and 2 is 5. So 595 kilocalories. As we estimating, it would be fine even if we just say 600. Emma has been asked to estimate the cost of renting an office. The graph shows how the annual cost varies with the total area of the office space. The annual cost of renting office space will increase by 5.75% next year. Estimate the cost of renting a 400 square meter office next year. Okay, so we have a scatter diagram and we need to draw the line of best fit. So 400 square meter, that is here. So that's between 60 and 70,000 pounds. So let's say 65,000 pounds. That's the cost now, and we need to increase this by 5.75%. So 10% of the 65,000, that is 6,500. So we're knocking off a 0. 5% is half of that. So we'll do 6,500 divided by 2. How many 2's fit into 6? That is exactly 3. How many 2's into 5? That is 2. And we have 1 remaining. How many 2's into 10? That is exactly 5. How many 2's into 0? That is 0. So 5% of 65,000 is 3,250. So we have the 5%. It says here an increase by 5.75%. But as we are estimating, it makes sense to round this to 6%. You can always work out the 0.75% and add it on top of the 5%. And that should be absolutely fine. However, since we're estimating, I'm just going to go and work out 1% and add it on top of the 5% amount. So 1% of 65,000, that is 650. So knocking off 2 zeros. So now I'm going to add the 650 on top of 3,250. So that is 10 here, carrying over 1. 8 and 1 is 9. So £3,900 increase, that is. So it's going to go on top of 65,000. So that is about £68,900 with the increase. Again, it's an estimate, so you could have slightly different answers there. Liam searches online for a choice of broadband services. He finds this graph. Broadband speed is measured in megabits per second. The lettered crosses in the graph represent the different services. What is the modal speed of these broadband services? So modal speed, that is the most common speed. So here we have the speed. So we're practically looking for the column with the highest number of crosses. So looking at 10, it has 3 of them. 35 has 4. 55 has 1. 60 has 1. So we can see that with 4, 35 is the modal speed. Using the graph from the question above, what percentage of these broadband services cost over £25 per month? Give your answer to 2 decimal places. So we're looking for over £25 per month. So there is cost per month, 25. So anything above this line. So we have 1, 2, 3, 4, 5, 6 out of 7, 8, 9, 10, 11, 12, 13, 14. So 6 out of 14. Going to give our answer as a decimal, so we'll do 6 divided by 14. How many 14s fit into 6? It's none. So we put a decimal point here now and into the answer, and we can add zeros after that point. So how many 14s into 60? Now you can round in your head the 14 to 15. So you know 15 and 15 and 15 and 15 gives us 60. So 4 lots of 15 give us 60. So we can say 4 lots of 14 that is 4 less than 60, which is 56. So now 60 take away 56 gives us 4. So we have 4 remaining here. And again we can add a 0 there. So how many 14s fit into 40? So we know 14 and a 14, that is 28. Can we fit another 14 to make 3 lots of 14? 8 and 4 is 12, so 2 down, 1 carried over. 2 and 1 is 3, and the 1 is 4. So that is 42, which is higher than 40. So we can't fit 3, we got to fit only 2. So we got 2 lots of 14, which is 28. So we're going to take away 28 now from the 40. So we're borrowing 1 from the 4. 10 take away 8 gives us 2. 3 take away 2 gives us 1. So we have 12 remaining. How many 14s into 120? You'll remember that 4 lots of 14 fit into 60. So it must be 8, so double. So 14 times 8. 4 lots of 8 gives us 32. So 2 down, 3 carried over. 1 lot of 8 is just 8. And the 3 gives us 11. So we have an 8 here. What do we have remaining? So 120 take away 112 gives us 8. So we have 8 remaining. Can add a 0. How many 14s into 80? So into 56 we could fit 4. So if I add another 14, get 10 here, 6, 7. So that gives us 70. So 5 lots of 14 gives us 70. 80 take away 70 gives us 10, so 10 remaining here. Can add a 0. How many 14s into 100? Well, 5 lots into 70. So if I add another 2 lots of 14, which is 28, that gives us 98, so very close to 100. So 5 lots and 2, that gives us 7 lots. Now at this point we can stop. We don't need to work out the remainders because I think we have enough digits. So we have 0.42857. That's as a decimal. Got to give our answer as a percentage. So this will be 42.857 so far. And our answer needs to have 2 decimal places. So 1, 2. This will be the cutoff point. So looking at the 7 here means we're going to round up. So this will be 42.86%. Hannah takes some items to market to sell. The scatter diagram shows the price Hannah paid for each item and the amount she sells it for. The line drawn on the scatter diagram marks the prices where Hannah makes no profit or loss. Hannah thinks she made a profit on more than half of her items. Is she correct? Explain your answer. Okay, let's pick two of these. This one, that's below the line. She paid £20 for that and she sold it for 15, so she sold it for less. Whereas this one, she paid 20 for it, but she sold it for 25. So practically anything above the line, she made a profit. Anything under the line, she made a loss. So Hannah thinks she made a profit on more than half of her items. Is this correct? So above the line are the ones she made a profit for. So we have 1, 2, 3, 4, 5, 6, 7, 8. So that is 8 out of the total, which is 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that is 8 out of 20. Is that more than half? No, because half would be 10. So we're going to say no. Model building blocks are sold in sets. The scatter diagram shows information about more sets that Noah sees for sale. Use the scatter diagram to estimate the price of a set containing 3,500 blocks. So we're going to need to draw a line of best fit in here. So 3,500, that is here. So going up, where does it meet the line? And that is between 150 and 200. So we can say £175. A, B, C and D are scatter diagrams. Which diagram shows negative correlation? Circle your answer below. So negative correlation is going to look like so. As one value increases, the other one decreases. And that is C. Laura has a company with 16 employees. Each employee has a device that records how many steps they take each day, their resting heart rate. The scatter diagram represents the data for 13 of the employees. The table shows the extra data for the other 3 employees. Laura takes an average of 4,000 steps per day. Use the scatter diagram with the extra data to estimate Laura's average resting heart rate. Give the units of your answer. You must show your working, which should be on the diagram. Before we can start with the line of best fit and the estimation, we need to add the data that we have here for the other 3 employees. So for one of them, average number of steps per day is 3,600 and the average resting heart rate is 96. So 3,600 with 96. So 3,600, that would be about here, because we've got these in thousands, and 96 was the heart rate, so this is 96. So where do these two meet? So we'll put a cross here. Next one is 3,400 and 100. So 3,400 is right here, and heart rate is 100, so we'll put a cross there. Then we have 3,199. So 3,199. Drawing the line of best fit now. So roughly through the points. And the question was asking to estimate Laura's average resting heart rate, and she takes on average 4,000 steps per day. So 4,000 is here, so going up that is about 98. Beats per minute. In total, the 16 employees had 70 days of sick leave last year. Each day of sick leave cost the company £130. Laura thinks that increasing the well-being of the employees may reduce the number of days of sick leave. She pays for gym membership for the 16 employees. The cost for each employee is £15 per month. Laura says if the number of days of sick leave is reduced by 40%, we will save over £750 per year after paying for the gym membership. Is she correct? You must show your working. So first of all, we need to work out how much these days of sick leave cost the company in total. So it's 70 days of sick leave for the 16 employees combined, and it costs the company £130 for each day. So what we're going to do is 130 times 70. Now, when you've got numbers like this ending in zeros, what you can do is multiply the non-zero digits, or non-zero numbers, I should say. So we'd have 13 times 7, and then add the 2 zeros after that. So if I put the 2 zeros at the end, I can now multiply 7 by 3, which is 21. So 1 down, 2 carried over. 7 times 1, or 1 times 7, is just 7, and the 2 is 9. So we get 91. So 130 times 70 is 9,100. So we've got the cost, £9,100 per year. Now, they're going to pay for gym membership for the 16 employees, and that is £15 per month. So 16 times 15, 5 times 6 is 30, so 0 down, 3 carried over, 5 times 1 is 5, and the 3 is 8. 1 times 6 is 6, 1 times 1 is 1. So 240 per month. for all the employees. So what we're going to do now is 240 times the 12 to get the cost per year. So 2 times 0 is 0, 2 times 4 is 8, 2 times 2 is 4. 1 times 0 is 0, 1 times 4 is 4, 1 times 2 is 2, 0, 8, 8, 2. So £2,880 for all the employees for the whole year, for gym membership that is. Now the question is, if the number of days of sick leave is reduced by 40%, then they will save over £750 per year. So what we're going to do is reduce the £9,100 by 40%. So 10% of 9,100, that is 910. So 40% will be 4 times that. 4 times 0 is 0, 4 times 1 is 4, 4 times 9 is 36. So this is how much would be saved with the 40% reduction. Or in other words, this is how much that 40% would have cost the company. Now, this is the figure that we're going to compare with the £2,880. So £3,640, take away 2,880. We're taking away 8 from the 4, which means we're going to borrow 1 from the 6. So 14, take away 8 gives us 6. 5, take away 8 means we've got to borrow 1 from 3. So 15, take away 8 gives us 7. 2, take away 2 is 0. So £760 saved. That is over 750. So is she correct? We're going to say yes. Here is a scatter diagram. 4 of the points are labeled. Which one of these points is an outlier? So outlier is a point that is outside of the range or different from the rest of the points. And as you can see, these are close to each other, whereas this one is not. So that is an outlier, point C. We now move into the calculator questions. The scatter diagram shows some information about 12 athletes who have run a race. Here is information for another athlete. Age 36, time 29 minutes. Plot this information on the scatter diagram. So there is age, so age 36 is going to be here, time 29 minutes, so that's right here. So where do these two points meet? That is here. Draw the line of best fit on the scatter diagram. There we have the line of best fit. Describe the relationship shown in this scatter diagram. This is a positive relationship. As age increases, so do the minutes, the time in minutes. The scatter diagram gives information about the temperatures at 8 different heights up a mountain. At a height of 1,000 meters, the temperature is negative 13 degrees Celsius. Plot this information on the scatter diagram. So 1,000 meters, that's here. Temperature is negative 13. So negative 10, 11, 12, 13. Draw a line of best fit on the scatter diagram. Use the line of best fit to estimate the difference between the temperature at a height of 550 meters and at a height of 950 meters. So 550 and 950. So 950 that's about -11, and 550 that's about -6. So the difference is 5 degrees. The scatter diagram shows information about the age and height of some trees. Describe the relationship shown in this diagram. The relationship is positive, so as age increases, so does the height, and it's a strong positive relationship. Because the points are very close to each other. It's almost like we've got a line here. So draw a line of best fit on the diagram. Estimate the age of a tree with a height of 625 centimeters. So 625, this is 700, this is 650, so 625 will be here. So age will be 23 years. Jaina is writing a report about wages. She has this information about the ages and weekly pay of 8 men. She wants to draw a diagram to see if there is a relationship between age and weekly pay for these 8 men. Draw a suitable diagram for Jaina. Okay, so we'll show age in years horizontally. Which goes up to 53. So 10, 20, 30, 40, 50, 60, so that works. Vertically, we'll show weekly pay in pounds. And the highest is 686, so about 700. So we could do 100, 200, 300, 400, 500, 600, 700, 800. So that works. Let's start plotting. So we have age 27, weekly pay 470. So going up to 470. Next one, age 41, pay 686. So about 690. Age 32, pay 514. Age 19, 295. Age 46, 612. Age 37, pay 578. Age 24, pay 338. Age 53, pay 615. So 620 roughly. So 53. 615. So we've drawn the scatter diagram, we've plotted the points practically. What type of correlation describes the relationship between age and weekly pay for these men? It's a positive one. So as age increases, so does the pay. Gina wants to compare the variation in weekly pay of men with the variation in weekly pay of women. She finds the range of weekly pay for a sample of 8 women is £437. Write a comment comparing the variation in weekly pay for men and for women. Support your comment with a calculation. Variation means how much the salaries or the pay vary. So it's another word for range. So we're looking at the highest and the lowest pay. So the highest pay was £686, and the lowest pay was 295. So we're going to do 686 take away 295. Which is 391. As you can see, the variation for men's pay is much lower than for women, which shows that pay is more consistent when it comes to men. So this is what we're going to say here. Should say men's, plural. Meaning it doesn't change much for men. Tom is studying science at college. He's learning about eyes. Tom does an experiment. He shows that the ratio of an ice cube's surface area to its volume affects the time it takes for the ice cube to melt. This scatter diagram shows his results. Tom has another ice cube. Each side is 2.5 centimeters long. Estimate how long this ice cube will take to melt. So we know that each side is 2.5 centimeters long. And the scatter diagram is looking at surface area and volume. So we need to work out the surface area and the volume of this cube before we continue to work with the scatter diagram. So volume, we can work out by doing 2.5 times 2.5 times 2.5, which is 15.625 cubic centimeters. Surface area, that is the combined area of all the different faces. So one face will be 2.5 times 2.5, and we know that a cube has 6 faces, so we're going to multiply that by 6. So 2.5 times 2.5 times 6 gives us 37.5. That is centimeters squared. So this is the ratio of surface area to volume. So surface area 37.5, volume 15.625. We can simplify this further. So 37.5, if I divide this by 2.5, gives me 15. And if I divide 15.625 by 2.5, gives me 6.25. I can divide these further by 2.5, so 6.25 divided by 2.5 gives me 2.5, and 15 divided by 2.5 gives me 6. Dividing this further by 2.5 so that we get 1 for at least one of these two values. So now 6 divided by 2.5 gives us 2.4. So 2.4 to 1 is the ratio. So this is 2 to 1, this is 3 to 1, so 2.4 is going to be here. Now I must say that this is the only question that I've come across in all the papers that I've ever seen at this level where it looks like you need to draw a curved line of best fit, so not a straight one. So I wouldn't worry about this because it's a very special case, but I'm gonna do it anyway. So as you can see, it looks like a curve, and this would go up to 13 minutes. You can see this in the way that the dots have been arranged. So it isn't the normal case where you've got the dots either closely together in a straight line or scattered around. So this is again a very special case that you're not really expected to see at this level. Jed is 65 years old. He drives a car but thinks his eyesight is not as good as it was. The scatter diagram shows the relationship between the ages of drivers and the maximum distances at which they can read road signs. What fraction of the drivers over 65 can read a road sign at over 400 feet? So that's the distance. So we're looking for over 400 feet. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 of them out of 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So that is 2/3. Jed says, using the scatter diagram, I predict that between the ages of 25 and 65, the maximum distance at which people can read the sign reduces by over 50 meters. Is Jed's prediction reasonable? Use the scatter diagram above to show how you decide. Use the conversion. 1 meter equals 3.28 feet. So we're going to predict the distances for these two ages, 65 and 25. For that, I need to draw the line of best fit. So 25 is here and 65 is here. So that is 520. And for 65, that is 380. So 520, take away 380. gives us 140. That is feet. So we need to convert that into meters now. 1 meter is equal to 3.28 feet. What about 140 feet? So what do we multiply 3.28 by to get 140? So we'll do 140 divided by 3.28 to work that out, which is 42.7 roughly. So we'll do the same here. One times 42.7 gives us 42.7 meters, which is not over 50 meters. So we're going to say no. It's not correct. P tests the super juicer. The manufacturer claims that 300 grams of apples will produce 2/5 of a pint of juice. P tests this claim by juicing different weights of apples and measuring the amounts of juice they produce. He uses his results to draw this scatter diagram. Is the manufacturer's claim correct? Show how you decide. Use the conversion. 1 pint is equal to 568 millimeters. So again, we're checking whether the manufacturer's claim is correct, which says that 300 grams of apples will produce 2/5 of a pint of juice. We need to draw the line of best fit first. So where is the 300 grams? That's here. So going up to where it meets the line, then across. So that is 250 milliliters of juice. Is that 2/5 of a pint? Let's have a look. One pint is equal to 568 milliliters. So 2/5 of 568. We work it out by doing 568 divided by 5 times 2. Which is 227.2. We saw that 300 grams of apples produces 250 milliliters. So that is more than 227. So is the manufacturer's claim correct? We're going to say yes, because it produces even more than that. And of course, this is estimation. When you use the line of best fit, you can't be absolutely certain. That's why we're going to say yes. The blitzed juice information states that the weight of juice produced from oranges is around 30% of the weight of the fruit. If Pete wants to produce 150 grams of juice, what weight of oranges should he use? So I'm going to try and represent this using a bar. So this would be the 100% amount. So that's the fruit. The orange is used to produce the juice, and the juice is only 30% of all the fruit used. So that is 30%. So now, if 30% is equal to 150 grams. So that means we've got 50 grams in each of these 10% divisions. So we've got 50, 50, 50, 50, 50, 50, 50, 50, 50, 50. So 10 lots of 50 will give us the total, the 100% amount, which is all the fruit that's been used. So that is 500 grams of oranges. Emma also buys cars. Bill wants to sell his old car. The car is 3 years old and in good condition. Emma uses a formula to work out the price that she will pay for Bill's car. P is equal to 12,000 times C times 0.75 to the power of T, where P is the price she will pay in pounds, T is the age of the car in years, C is the condition of the used car according to this table. The scatter diagram below shows the prices paid online for the same model of car in good condition. How much more would Bill expect to get if he sells his car online instead of selling to Emma? So if selling to Emma, how much would he get? Let's work that out first. Emma uses this formula and we'll work out the price by replacing letters with the numbers and doing the calculations. So 12,000 times C is the condition of the used car. So the condition was good. So good gives us 0.9. So times 0.9 times 0.75 to the power of T. So T is the age of the car in years, and that is 3. So we'll do 12,000 times 0.9 times 0.75 to the power of 3. What is that? 0.75 times 0.75 times 0.75, which is 0.421875. Okay, now we can just multiply the three numbers. And that gives us £4,556 and 25 pence. Now we're going to compare this with the online price, which we're going to work out through the scatter diagram. So the car is 3 years old. That is nearly £9,000, 8,800, because each of these small squares represents 400. How do you work that out? As you can see, this big square goes from 8,000 to 10,000, so there is a £2,000 step. So 2,000 divided by these 5 small squares gives us 400. So £8,800, and we've got this amount that Emma would give him, so we're going to work out the difference. So 8,800 take away 4,556.25. All applicants who attend the interview complete an initial assessment. Now has the scatter diagram about the results of the initial assessment. What fraction of applicants over the age of 26 scored more than 40 marks? So we're interested in the applicants of the age of 26 who scored more than 40 marks. So we've got age 22, 24, 26 is here, and more than 40 marks. So it's 1, 2, 3, 4, 5 out of the total, which is 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. We can divide both numbers by 5 and we get 1/7. A cafe owner wants to know how many cold drinks she is likely to sell next week. She makes a record of sales of drinks over the last 2 weeks. She wants to use this information to see if she can predict the number of cold drinks she is likely to sell based on the temperature forecast for a particular day. Use the graph paper to show clearly the data she has collected in a way that will help her to do this. We have space for working out. So we're going to draw a scatter diagram focusing on the cold drinks. Horizontally will show the number of cold drinks sold, and vertically will show the temperature in degrees Celsius. So the highest number of cold drinks sold, that is 40. Into 10, 20, 30, 40, 50, 60, and so on. And the highest temperature is 20, 23 in fact. So we need to go up to at least 23. So we can go up in twos, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Let's plot the points. So we've got first Monday, temperature is 17, number of cold drinks sold is 24. So 17, 24. Tuesday, 18, 26. Wednesday, 17, 25. Thursday, 19, 30. So 19, 30. Friday, 20 and 32. Saturday, 20 and 28. Monday, 19, 27. Tuesday, 19, 29. Wednesday, 22, 35. Thursday, 23, 40. Friday, 20, 30. Saturday, 20, 34. So we've got all of the points plotted. Now we're going to draw the line of best fit. The weather forecast for next week says it will be 21 degrees Celsius on Monday. What can you tell the cafe owner about how many cold drinks the cafe is likely to sell on Monday? Show clearly on your graph paper how you found your answer. So, I'm going to look for 21 degrees Celsius. So that is in between 20 and 22. So that's right in the middle. So that would be about 33 drinks. So we're going to say the cafe is likely to sell 33 cold drinks. I should specify because we have hot drinks as well. A magazine article has this headline: Garden birds in decline. Fewer birds seen in our gardens. An environmental organization records information about bird populations. The graph shows some data about two types of garden birds. Is the magazine headline correct? Show suitable calculations of percentage changes for the last 10 years and draw trend lines on a graph to support your answer. So we'll do two things: calculate percentage changes and draw trend lines, which are lines of best fit. So starting with the percentage changes, we've got two birds, chaffinch and sparrow. So starting with chaffinch, in 2009 there were 4 of them. So now in 2018 there are 2 of them. So 4 take away 2 gives us 2. That's 2 out of the original, which was 4. So that is half, which is 50%. So that's a 50% decline for chaffinches, that is. Now drawing a line of best fit, you can also see a decline here. For sparrows, 2009 we've got 5, 2018 we've got 5 as well. So that shows no decline, but the trend line does show some decline. So we're going to make 2 comments. One, we're going to focus on percentage changes, and the other one on the trend lines. So what I'm going to say is that chaffinch birds experienced a 50% decline, whereas sparrows have seen no decline or no percentage change. Now the trend lines show a decline for both birds, more for chaffinches than for sparrows. A man is 185 centimeters tall and weighs 98 kilograms. He wants to reach a healthy weight. A doctor says he can lose 0.75 kilograms a week if he follows a diet and exercises to burn 600 calories a week. He plans his diet and decides to use yoga exercise to burn 600 calories a week. He will use 1-hour yoga classes that burn 200 calories. Each class costs £6. He has £360 he can spend on yoga classes. Does he have enough money to pay for the yoga classes? Explain your answer using figures. So he is 185 centimeters tall and weighs 98 kilograms. 185 centimeters, that's this line here, and 98 kilograms is this point here. So he has unhealthy weight. To get into this healthy range, he needs to be 84 kilograms at most. So from 98 to 84, he needs to lose at least 14 kilograms. So how many weeks is that? 14 divided by 0.75 gives us 18.67. So we're going to say 19 weeks, because 18 won't be enough anyway. So 19 weeks. Each week he will need to do 3 classes, because in each class he will burn 200 calories and he needs to burn 600. So that will be 3 classes each week. So that's why 3 times 19 times £6 per class should give us the total cost, which is £342. He has 360, so that is enough. So he has £18 more than he needs. A vet nurse in a pet rescue center records weights and ages of kittens brought to the center. One day the center receives an abandoned kitten. It weighs 460 grams. The nurse needs to estimate the age of the kitten. Draw a suitable graph and trend line. Estimate the age of the abandoned kitten. Show on the graph how you made the estimation. So on one axis we'll show weight in grams, and on the other age in days. Doesn't matter which one we show where when it comes to scatter diagrams. I'm going to show age in days. Horizontally, and weight in grams vertically. The highest number for age is 56. $10, $20, $30, $40, $50, $55, so that doesn't work. So we'll do 10, 20, 30, 40, 50, 55, 60, 65, 70, 75, 80. The highest number for weight in grams is 720. So we'll go 100, 200, 300, 400, 500, 600, 700, 800, 900, 1000, 1000 and 100. Let's plot the first one. So weight 600 grams, age 50 days. So 600 and 50 there. 340, 28. 340, 28. 480, 42. 360, 20. 660, 50. 720, 56. 420, 28. 180, 14. 'Drawing the line of best fit, we can now estimate the age of the kitten that weighs 460 grams. So 460 that will be 36 days old. We're going to give our answer in weeks. So what we're going to do is 36 divided by 7 gives us 5.14 weeks. The garage sells used cars. When a customer buys a car, the garage owner will offer an amount to pay for the old car. A customer brings in a ZZX Roadster with a mileage of 70,000. The garage owner estimates the value of this car based on the mileage. He uses this website graphic to find this value. He wants to make a first offer to the customer 30% below this value in order to make a profit when he resells it. What amount should he offer the customer? So 70,000 miles. That is 3,400. We're going to take away 30% of it. So 30% of 3,400. We do 30 out of 100. times 3,400 which is 1,020. So 3,400 take away 1,020 gives us 2,380. So the estimated value of the customer's car was £3,400, and the first offer to the customer is £2,380. This is a table of the heights and shoe sizes of some of the children at the nursery. Draw a scatter diagram to represent this data. This is a table of the heights and shoe sizes of some of the children at the nursery. Draw a scatter diagram to represent this data. So we are going to represent the height in centimeters and the shoe sizes. Which one to represent where? It doesn't really matter, but looking at how much space we have available, it makes sense to represent shoe sizes vertically because they only go up to 11, and the height in centimeters horizontally because they go up to 106. So starting with the shoe sizes, go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm not sure if there is a size 13 or 14, so I'm going to stop at 12. But you don't lose any marks even if you continued. So now horizontally we'll show height, which again goes up to 106. So trying 10, 20, 30, 40, 50, 60, 70, 80, 90, 95, so that doesn't work. So we'll do 10 here, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, 160, 170, 180, 190. That is centimeters. Plotting the point, we've got Ben with a height of 98 centimeters and shoe size 11. So 98 going up to 11. Then Rosie, 104, 10. Holly, 94, 9. Eva, 106, 11. Samira, 81, 6. Tom, 85, 6. Nico 92.9. Cameron 95.10. Rakib 91.9. Joseph 89.7. What type of correlation does this graph show? Write your answer in the box below. This is a positive correlation. As you can see, as height increases, so does the shoe size. What is the mode shoe size of the children? So the most common shoe size. It's 9, because we've got 3 points in here. And we can confirm it in the table. So we have 1, 2, 3 9s in here. There are 2 11s, 2 10s, 2 6s, and so on. But there are 3 9s. Identify the types of correlation in the following scatter graphs. We've got 2 of them, A and B. A, as you can see, the line of best fit goes downwards. It's a negative correlation. So when the values of one of the variables go up, they go down for the other one. So roughly 5 here matches with 110 here, whereas as that 5 increases, so this variable here increases, so it goes to 20, for example, that would be matched with 60. So it's gone down for the variable that we're representing vertically. So A is definitely a negative correlation. B is positive, so it goes upwards, the line of best fit, and also that's 2 matched with about 300,000, whereas 10 that's matched with about 50,000, so they've both increased. So it's a positive correlation. Khalid wants to buy a 2-bedroom house no further than 0.6 miles from the station. Khalid has saved a deposit of £4,875. He can afford a mortgage of 3.5 times his earnings, which is £28,145 per annum. The scatter graph shows information about the price and distance from the station of recent 2-bedroom house sales in the area. Can Khalid afford to buy a 2-bedroom house within 0.6 miles of the station? Give a reason for your answer. 1 mile is equal to 1.6 kilometers. So we have here the scatter diagram, and we're going to draw the line of best fit. So we're looking for 0.6 miles from the station, and we know that 1 mile is 1.6 kilometers. What about 0.6 miles? To get from 1 to 0.6, we'll multiply 1 by 0.6. So we'll do the same here. 1.6 times 0.6 gives us 0.96 kilometers. So 0.8, this will be 0.9, 0.95, so about here, 0.96. So it's in between 104,000 and 106,000. Bang on in the middle will be 105,000. So this is in between the two roughly. So what is in between 105,000 and 106,000? So that will be 105,500. Pounds. So that is the price of the house. And what can he afford? See, he has a deposit of 4,875 already, and he can afford a mortgage of 3.5 times his earnings. So we'll do 3.5 times 28,145. That is 98,507.5. And we need to add to that the deposit, which is 4,875. And that gives us 103,382 pounds and 50 pence, which is lower than 105,500 pounds. So can he afford? We're going to say no. Given a reason for your answer, so he can only afford 103,382 pounds and 50 pence. Or no, he can afford only this amount. That makes more sense. Pete wants to rent an apartment near Norwich city centre. He records information about 10 apartments on a scatter diagram. The diagram shows the distance from the city centre in kilometres, the weekly rent in pounds. The table shows extra data about 2 other apartments. Pete rents an apartment for £280 per week. Use the scatter diagram with the extra data to estimate the distance from the city centre to the apartment. You must show your working, which should be on the diagram. As we need to use the scatter diagram with the extra data, first thing to do is to plot the extra data. So we've got one apartment, distance from city centre is 2 kilometres, weekly rent £250. So there is 2 going up to £250. And the other apartment, 3.2 kilometers away from the city centre, so there is 3.2, so going up to £180. So that will be here. So we've plotted the extra data. Now we're going to draw the line of best fit so that we can estimate the distance for that particular apartment. So the rent is £280 per week. So 280, that's going to be here. So that is about 2.8 kilometers from the city centre. And that's the end of the questions.